What's up guys, welcome back. So today we're going to do some trig identities and we're basically just going to do a bunch of different examples, nothing too crazy. On the right hand side you can see I've included the reference sheet so you can kind of follow along in terms of where I'm pulling these identities from. But just as a rule of thumb, I think to get better at these you just got to do as many as possible. And I'm talking a lot just to get experience and understand the different techniques and tricks you can use. And I think it would be beneficial to kind of keep the reference sheet or the formulas away from you and the identities like hidden until you get good at kind of recalling it just off the top of your head. But figure out what works for you. With that said, let's get into it. All right, so here we've got simplify sine theta, cot theta. Now, I know that cot theta is the reciprocal of tan, but I also know that tan theta is sine theta on cos theta. Okay, so that's one of the identities, and I don't think I can see it here, but that is one of the identities. So I know cot is a reciprocal of tan. That means cot must be just the flipped version of tan. So this must be cos theta on sine theta. So therefore this would be sine theta times cos theta on sine theta. These obviously cancel out, so you're left with cos theta. Okay, done. Okay, next one, tan x cosec x. So we're doing a simplify once again. So let's use what we did before with tan x, and let's say tan x is equal to sine x on cos x. So sine x on cos x. All right, now cosec, as you can see on the right-hand side, cosec is 1 on sine. So I'm just going to switch that out for 1 on sine. So 1 on sine x. These will obviously cancel, so we're left with 1 on cos x. And that can also be reduced into simpler form. So as you can see on the right-hand side, 1 on cos x is sec x. So here I'm going to say sec x. Okay, let's do this one. So once again, simplify cos x plus sine squared x on cos x. Now, whenever I do these ones with fractions, almost always you're going to need a common denominator. So let's go ahead and do that. So that's under 1. So the lowest common denominator of 1 and cos x would be cos x. The right-hand side is going to stay the same because the bottom hasn't changed. And so on the left-hand side, I'm multiplying bottom by cos x, so I have to multiply the top by cos x. So that's going to be cos squared x. Now, hopefully you can kind of see that this cos squared x plus sine squared x is over here. Now that's equal to 1, so that's nice. 1 on cos x. And once again, 1 on cos x will be sec x. Done. All right, now we're moving on to these prove questions. So proving questions, you've got a left-hand side on this side of the equal sign and the right-hand side on this side of the equal sign. So typically you want to choose one side and make it look like the other side, and you want to choose the one basically that looks a little bit more complicated, so you have a bit more to work with. And then sometimes you have to manipulate both sides, but let's just see how we go. So first of all, I'm going to choose the left-hand side. I'm going to try and make the left-hand side look like the right-hand side. All right, so I know that cot x is 1 on tan x. So let's just try that, plus tan x. All right, like I said before, if it's a fraction, you probably need to make one common denominator. So let's just do that. So that will be tan x. This will be 1. This will be tan x. So I'm timesing bottom by tan x. I need to times the top by tan x. So that's tan squared x. All right, now this one here isn't actually on the reference sheet, but let me show you where it comes from. So it comes from this one here. And what we want to do is basically divide all these three terms by cos x. So when I do that, I'll have cos x divided by cos x. Well, that's 1. Plus sine squared x over cos squared x. Well, that's going to be tan squared x. And then also 1 divided by cos x. Well, that's going to be sec squared x. So this is one of these identities off the Pythag one, as you can just see here. That's called the Pythag identity. Okay, now here you can see 1 plus tan x is sec squared x. So let me switch that out on tan x. Okay, and then you look at this and you say to yourself, all right, I'm here, but it doesn't really look like that. So what can I do? Okay, so I notice on the right-hand side, I have cosecs and secs. Now I don't have any tans, so it might be beneficial to get rid of the tan. So I know that sec squared x is divided by tan x. Now tan x is sine x on cos x as well. Okay. So what I'm going to do is I'm going to flip that because we're dividing. So that's sec squared x times cos x on sine x. Okay, so you'll notice that I'm still not quite there yet. So sometimes you just got to play around with it, and let's just see what we can do. Now I know that sec squared x is also 1 on cos squared x, times cos x on sine x. And now I can do a cancellation. So I've got cos squared x on the left-hand side and cos x on the top right-hand side, so cross one off. And now I'll have 1 on cos x times 1 on sine x. And hopefully you can see that that is going to be sec x is the cos x reciprocal, and then cosec x is the sine x reciprocal. So therefore we do have cosec x sec x. Therefore left-hand side equals right-hand side. Okay, now I just want to make that clear. That is this bit here, and then this bit is that bit there. Now, sometimes you will do a process like this, and you probably went longer than you needed to, because now that I'm looking back at it, I could have chosen an easier option by turning all of these at the very start into sines and coses. But in any case, it just goes to show there's more than one way to get to the solution. Okay, next question. So now we're trying to prove this thing. So it's a little bit more complicated, and it's clear the left-hand side is going to be easier to work with. So let's start there. Now, as I said before, you're probably going to need to make one denominator. So the lowest common denominator of these two, it looks like will just be the multiplication of those two. So we're going to have sine theta on 1 plus cos theta, sine theta on 1 plus cos theta. And the top, okay, so I'm going to multiply this by this. So I'm going to have 1 plus cos theta all squared plus sine squared theta. Okay. Now what do we have? So expanding the top left, I'm going to have 1 plus 2 cos x plus cos squared x plus sine squared. I just realized I did all x's, so let's change them to thetas. Okay, all over sine theta 1 plus cos theta. Now I'm not expanding it yet, just in case I can cancel anything. So here we go. What do I see? I see cos squared theta plus sine squared theta. I know that is 1. Okay, so let's go. So 1 plus 2 cos theta plus 1 over sine theta 1 plus cos theta. Obviously 1 plus 1 is 2, so 2 plus 2 cos theta over sine theta 1 plus cos theta. Okay, so what do I notice on the on the right hand side? I've got a 2 here. Now I can see these two can factorize, so taking those out, I'll have 2 bracket 1 plus cos theta over sine theta 1 plus cos theta. And what do you know? They cancel. 2 on sine theta will be 2 cosec theta. Okay, last one for today. So once again, fraction business, let's get it to one denominator. Now, hopefully you'll notice that these two, when they multiply, because they've got to be the lowest common denominator, that's actually different to 2 squared. So sec theta minus 1 and sec theta plus 1. So let's just do one entire fraction and say this is sec squared theta minus 1. Okay, because that is the expansion of it. Now, okay, now the top left, you're going to have tan theta outside of sec theta plus 1 minus tan theta outside of sec theta minus 1. Okay, now what else can we do? Now I can see a few things. First of all, I can see I got tan thetas in there, and I can also see that okay, is also an identity we did from the one before. So let me copy that over. Okay, so you can see I've pasted it up there. Now sec squared theta can be rearranged, right, to make this tan squared x equals sec squared x minus 1, which is what we've got in the denominator, okay? So we're gonna be able to switch that out. So first of all, let's factorize the top. So tan theta outside of sec theta plus 1 minus sec theta minus 1. So just be careful with the brackets there, okay? Now all over, now sec squared theta minus 1 we just said is tan squared theta. Here we can do some cancelling. So that one goes, that leaves a tan theta at the bottom. So what does the top simplify to? You've got sec theta minus sec theta. Well, that cancels out. And then you're going to have this bit, which is 1 minus minus 1, which is 2, isn't it? So that's 2 on tan theta. So now we have 2 over tan theta, and the reciprocal of tan theta in the denominator is cot theta. So we're going to have 2 cot theta, which is equal to the right-hand side. Okay, so that's just a quick introduction. Hopefully that's enough to get you started on some easier and harder questions. If you like this video, let me know. And if there's any other videos you want to see, hit me up in the comments. Peace.